we are now going to move on from interference to diffraction. So interference and diffraction, they are actually very related to each other. So let's probably spend some time to talk about the differences between interference and diffraction. Okay, so previously we already studied the interference pattern where you have two light waves overlap with each other. So in the double slit section, you learn that these two light wave comes out from the two slits that you have created on an opaque board. So the two slits will have light transmitted through it, and the two light wave will overlap in the same region. Then you observe a pattern on the screen. And in the next section, we talk about thin films. So thin films, you have light reflected from the upper surface of the thin film and the lower surface of the thin film. So the two reflected light will interfere with each other in the region above the thin film usually. So that's another kind of interference. So usually when we talk about interference in those two sections, it's always two light wave, two transmitted light wave or two reflected light wave. But now we are going to investigate interference due to overlapping many light waves together. So I believe you see the key idea between interference and diffraction is one is the overlap of two light waves, usually a small number of light waves. But when we talk about overlapping many light waves, it will be called as diffraction later. Okay, a good example of diffraction is the behavior of waves after they pass through a slit or an aperture. So a slit and aperture, they are basically the same thing. Basically, it just means by a small region which we allow wave to pass through. Okay, so it's usually like a pinhole or like a very small slit over there. Okay, so if we have wave passing through this kind of slit or this kind of aperture, diffraction will occur. Okay, when part of the wave is cut off by some obstacle, we observe diffraction effects that results from the interference of the remaining parts of the wavefront. So we mentioned that if we have a slit, right? So if we have a slit is basically a whole piece of opaque object, but a single region which you leave it open for wave to pass through. So that opaque board here will be our obstacle. So this obstacle here is going to block a big portion of the wave, leaving only a small portion of the wave to pass through the slit, okay, or pass through the slit or the aperture. Okay, we will observe diffraction effects that results from the interference of the remaining parts of the wavefront. The remaining parts of the wavefront is the wavefront that managed to pass through this small region over here. This small region, you have wave passing through, right? The wavefront that passed through, even though the whole wavefront is supposed to be this long, but because you only have a slit of this width, only the wavefront of this width managed to pass through the slit. Okay, and that small part of wavefront here will be the reason why diffraction occurs, because this small part of wavefront here, you can think of every point on the wavefront to be a source of secondary wavelets based on Huygens principle. Okay, we are not going to talk too much about it. We are going to move on to the next video to talk about Huygens principle and how we use it to understand diffraction. But for now, you just need to know that there's a small piece of wavefront that passes through the aperture. So this small piece of wavefront, they will undergo interference with each other, and that effect causes diffraction. Okay, so we use the term interference for effects involving waves from a small number of sources. Okay, a small number of sources, like in the previous two sections, for thin film is only two reflected light, for double slit is only two transmitted light. So usually it's a small number of sources, usually two. But diffraction usually involves a continuous distribution of Huygens wavelets across the area of an aperture or a very large number of sources or apertures. Okay, so basically for diffraction, how is it different from interference is you have a lot of sources. Okay, you have a continuous distribution of sources, but it's not like you have many slits. It's just that you have a continuous distribution of Huygens wavelets. Okay, you have to understand Huygens principle in order to understand why I say it's a continuous distribution. But don't worry too much about it, because I'll explain in the next video also. So basically in the slit, there's wavefront passing through it, right? Based on Huygens principle, you know that wavefront, every point on that wavefront will be a source of secondary wavelets. So there will be secondary wavelet coming out from all points on the wavefront. So this is the continuous distribution of Huygens wavelet that they're talking about. This small wavefront over here, every point will act as a source for Huygens wavelets. So it's a continuous distribution of Huygens wavelets across the area of an aperture, or a very large number of sources or apertures. So there's many waves overlapping with each other. Okay, so but both interference and diffraction are consequence of superposition and Huygens principle. So the key message that you should take away is that interference usually involves two or a few sources only, but when we talk about diffraction, it's usually a continuous distribution of sources or many sources. Okay, so let's look at a simple diagram to understand the idea. So on the left here, you can see interference. For this one, you can see there's a blue circular wave and green circular wave. Blue one representing the circular wave emitting from the upper source over here. The green circular wave represent waves emitting from the lower source over here. But basically, there's only two sources only, so it's an overlapping of two waves only. So this kind of pattern we call it as interference. Okay, but when we move on to diffraction, you can see that I have labeled many points over here. So each point over here will be emitting its own Huygens wavelets. You can think of it like that. Okay, based on Huygens principle, each point over here will be emitting its own Huygens wavelets. So I label each source to be emitting different color wave. Like this one is a blue wave, it's a purple wave, it's a red wave, orange wave, yellow wave, green wave, blue wave, purple wave. So each point over here acts as a source for secondary Huygens wavelets to be emitting out from it. So all these waves will overlap in the same region. So you can see that it's an overlapping of many light waves. They are coming from each of these points over here. So this overlapping of many sources over here, we call it as diffraction. Okay, so that's the main differences. One is two sources only, one is a continuous distribution of Huygens wavelets. Okay, so in the next video, we'll be talking about how we can use the idea of this Huygens principle to study the diffraction caused by a single slit.